So this is the halogens. We were discussing group 7. Okay. So that was the chapter heading. And the topic that we were on were the reaction of concentrate H2SO4 with the solid group 1 halides, and we took at sodium chloride, sodium bromide as an example. So that's where we were currently doing. So the heading, what we are continuing is the reactions of group 1 metal halides with concentrated H2SO4. So this was the current subheading going on. And in this, the first one was with sodium chloride solid. That was already done. And the second was sodium bromide, which was also already done. I need you to confirm that these two are already done and you have this in your notes. Could you please let me know quickly, please? Just mention that in the Zoom chat. We already have the equation with sodium chloride and sodium bromide. So with sodium chloride, we saw the misty white fumes of HCl coming out, and with sodium bromide, we got misty white fumes, we got brown fumes, we also had colorless gas with a choking smell, remember all that. And we did two equations there. The first equation forming the HBr, and the second equation forming the SO2 and the bromine. So that was the reactions with the NABR. So I am now at the third part here. So this is where we are picking up. Okay, so this is sodium iodide. So let's see what happens when sodium iodide does the reaction. The point that we are trying to prove, if you remember the last class, we also said something about the reducing ability of the halides. In the reducing ability of halides, I said iodide happens to be the strongest reducing agent. Okay, so because so the chloride is the weakest among the chloride, bromide, and iodide. Chloride is the weakest reducing agent. So when we look at the reaction of any sodium chloride with concentrate H2SO4, we saw HCl gas coming out, misty white fumes, and there was no further reaction. The chloride in the HCl continued to remain as chloride. It did not get oxidized into Cl2. Then when we looked at NABR, we found the HBr coming out, and then the HBr then, as I said, converted into SO2 and the Br2. So they were, and that because the bromide is a bit more stronger reducing agent than chloride. And now I'm going to compare that with the iodide, trying to understand what kind of reducing agent is iodide, and so what happens in the reactions because of it. Okay, good reactions, good examination points. Definitely you got to memorize them. Okay, so observation. First of all, we'll write the observation, and then we'll try to understand with the help of reactions why are those observations being seen. Okay, so let's have a look at the observations that you will notice when sodium iodide reacts with concentrate H2SO4. Okay, so the first observation is you will get misty fumes, and this misty fumes is going to be purple. And the misty fumes, the reason why we see is because of HBr gas which is coming out. The misty white fumes is the HCl, remember that. And the second observation that we will also notice is we'll also see purple fumes coming out. So we need to understand why this is happening. You could say fumes, you could say vapor, both are fine. Or you could also say black solid being formed. So if you say black solid, or you could say purple fumes. Okay, so that is because of the iodine which is being formed there. Okay, so that's the just give me a second. Okay, and then we'll also have a third observation. The third observation is going to be a colorless gas is going to come out. A colorless gas with choking smell. So once again, the same issue. And the colorless gas which has the choking smell is the one and only sulfur dioxide there, which can do that. So we have sulfur dioxide also coming out. So this is, if you compare this with the NaCl and NaBr, you already notice there are some extra comments that you're getting to see here. And this one, you will also get a yellow solid here, and that yellow solid is the sulfur solid that you're going to get. And there is a fifth one, 5 observation. Now this did not happen when NaCl reacted. You only got one observation. And if you just check your notes of the previous class, NaCl, when it reacted with concentrate H2SO4, only white misty fumes, only HCl was get formed. But when NaBr reacted, you got white, you got misty fumes, you got the brown fumes and the choking smell and all that. Now we are getting 5 observation. The fifth one is you will get another colorless gas, and this gas is going to smell like rotten eggs, literally, with rotten egg smell. Not exactly very pleasant to be around with, and that is the hydrogen sulfide, H2S. This gas is called hydrogen sulfide. So there's a lot of observation which is going to happen when sodium iodide reacts with concentrate H2SO4. Okay, so let's have a look at all those reactions which can actually happen here. Okay, please remember the main point which I'm trying to hit here is that the reducing, so this is the reason of all of that. So reducing ability increases from the chloride ion to iodide ion. Okay, so iodide ion happens to be a reducing agent and a very good reducing agent there. And don't forget, the concentrate H2SO4 is an oxidizing agent, so that's where the more stronger reducing agent does a lot of extra reactions as compared to the weaker one. Okay, if you're ready, just type R for ready if you are. Then we'll go to our next page. Let's have a look at a bunch of equations that actually happens when sodium iodide reacts with the concentrate sulfuric acid. Don't forget, this reaction will not happen if it is dilute H2SO4. Okay, please let me know if I can go to my next page. Okay, anytime you want me to go back to a previous page, please let me know. Okay, so let's have a look at the reactions which are happening. So the first reaction that happens is that's the sodium iodide who is reacting with the H2SO4. And what we get is the NHSO4 as usual. That's the first ionization of sulfuric acid. We spoke about all of that. And then I will get here the hydrogen iodide. So that's the hydrogen iodide, that's the misty purple fumes. So that's where that's coming from. Okay, and then there are a lot of reactions which is happening. It's all happening one after the other. Okay, so the second reaction is, so now this hydrogen iodide, it can continue the reaction. Now remember, the HCl which was formed could not continue the reaction, correct? But the HBr which was formed in the previous class, that could continue the reaction to form the Br2 and the SO2. But now there's a lot of extra reaction which is going to happen. So that's what your mind has to be ready to understand. So the HI can react with H2SO4 and it can form H2O, plus it can form sulfur, plus it can form iodine. So I'm just trying to save you some time with the balancing as well, because you ultimately, end of the day, you've got to memorize these equations. So if you learn of this equation there, so that explains the yellow solid. So that's the one which is coming out as yellow solid. And this is the purple fumes. Either you can say purple fumes. If you're going to say purple fumes, so iodine has to be gas, sulfur has to be solid, Or if you say black solid, if you say black solid, then you have to mention iodine as solid. So it depends on what physical state you're going to use. Of course, H2O is liquid, and that is liquid is concentrate H2SO4, and the HI comes off as gas. Okay, so that's one equation that is happening. But since there are some other equations which can also happen, HI can react with H2SO4 in more than one way. Because don't forget, the iodide is a pretty strong reducing agent, so it can do a multiple set of equations with the H2SO4. Okay, I didn't balance the equation. Just to save time, if it's okay with you, I'm just going to write the numbers here. Is that okay? And if anyone has any doubts, please let me know. So that's the numbers there to quickly balance the equation. HI can also react with H2SO4 in a different way, and this can result in the formation of H2S, that's the hydrogen sulfide gas. It can even come this way, or and of course the H2O liquid, and it can form the iodine. So once again, the same story there. I can form that's the rotten smelling gas which smells like rotten eggs. This is the one which smells like rotten eggs. That's where that's coming from. Now remember, when you do this reaction in a test tube, multiple reactions are going to happen, which means you should expect all of these to actually happen at the same time. Okay, so that is the important point here that you must keep in mind. And to balance equations, once again, just to save time, put here 8 and put here 4 and put here 4. And once again, it depends on what physical state you're going to mention. If you're going to mention this as gas, then you will say purple fumes. Or if you're going to mention iodine as solid, that's going to be like black solid. Once again, for those kids who just joined in late, what's currently going on is this. So what's happening is we started off with the reactions of, we continued from where we left off in the previous class. We were doing reactions of the group 1 metal halides with concentrate H2SO4. Concentrate H2SO4 is an oxidizing agent. The halides are reducing agents, and the main point here is the reducing ability of the halide increases from chloride to iodide. So we did equations with NaCl and NaBr already. We are now currently doing reaction of sodium iodide. Keep in mind, iodide is the strongest reducing agent. So when we do, these are the 5 observations that you get, and I'm trying to write the equations to make you understand why those observations came. So that's what currently is happening. Okay, so this is all reactions happening when the sodium iodide reacts with concentrate H2SO4. All of them are happening one after the other. So there's another reaction which is happening. So the hydrogen iodide which is formed can also react with H2SO4 in a different way. That's the fourth and the final equation. And in this equation, I can even get the SO2 gas, plus I'm getting H2O everywhere, and plus I will get the iodine gas. So once again, the same story. The observation, we're just trying to understand the purple fumes coming in from there. This is the colorless gas. This is the colorless gas with a choking smell. There you go. And balance the equation very quickly to save some time. I'm just putting here 2 and I'm putting here 2. Okay. Now the point I'm trying to make is, if the questions are like, who was responsible for the misty purple fumes, so you know that one, HI, correct? So that was HI gas there. This was the solid, this is the liquid, and this comes off as it's going to come off as, because H2SO4 liquid has some amount of water in it, so the NaHSO4 is going to come off as an aqueous there. And who formed the purple fumes? That was the iodine gas which is formed. Who formed the yellow solid? So that one there. Again, H2S smells like rotten eggs. Purple fumes. So you should expect questions which will ask you to write equations with respect to the observation. Okay, so if the question says write an equation to show the product formation which is responsible for a rotten smelling gas, and a purple fume. So you probably have to write the fourth equation. So please read the question carefully. Of course, I'll be sending you a bunch of past paper questions on it, and expect these kind of questions in long answer questions also. Okay, that's where you have to be a bit careful. So you have to know all the reaction. You cannot just choose to learn any one particular. Okay, so please remember, this is a very unique situation. Sodium iodide, the way it reacts with H2SO4 is very different. It has got bunch of observation. Remember, there are 5 observation it can show, and then you should be able to justify the 5 observation with these 4 equations. So these 4 equations tells you correctly why did those 5 observation happens. Okay, so I'm done with this. Waiting for your questions. If you have, let me know. Please let me know if you have any questions for me. Anyone has any questions? Okay, so that was the end of the reaction of concentrate H2SO4 with metal halides. I will be sending you a copy of all this once the class gets over. Nothing to get worried. So if you're ready, let's start the last part of this chapter. Any questions? And guys, I'm still waiting for someone to send me a copy of the last class notes on my WhatsApp, please, which I sent you. Okay, and so these are the equations that happens. Everything ready? You got to memorize these equations. Remember, very probable long answer question could be based on this particular equations. Okay, so the last bit of this chapter now is again a very repeated area of the exam. This is test for halides. Test for halide ions. So the halide ions that we are going to test is the chloride, bromide, and iodide. So what kind of chemical test can you do to confirm the presence of these ions in a chemistry lab? So this is very good area, easy area. Small easy equations. You have to learn what's the test, you have to learn what's the observation, and you have to learn how do we write an equation for it. Okay, so very good area for the exams. Please do take care of it. Once again, a reminder, past papers of 8B and C is coming to you today. So finish off the learning. Make sure that you do all this work before school opens up, so you have a time to quickly finish any of the work that is left behind. Okay. So the first of all, what we are going to do is the test for chloride. So, okay, so test means what exactly you're going to do. What are you going to do? So you're going to add silver nitrate solution. So basically what we're going to do, we normally, silver nitrate solution is the main reagent that we're going to use here, okay? So AgNO3 aqueous. Okay, so this is silver 1 nitrate. Now the reason why I'm calling it silver 1, because silver's oxidation number is +1. It's a transition metal. So instead of saying silver nitrate, it's always good to say silver 1 nitrate. Okay, so we will add that in the form of a solution, and then we'll say followed by ammonia solution. Ammonia, which is your NH3 aqueous solution. Okay, which means I'm going to use 2 reagents here. The first, I'll add silver nitrate. I will see what observation will I get, and then into that I'm going to add ammonia solution into that particular thing, whatever I see, and then I will again see something, and based on that I will confirm if chloride is present or no. Okay, so this is the test. Okay, so sometimes they'll ask you what's the test and what's the observation. So okay, let's write down the observation. So what will I see? And yes, you have to learn the reactions as well. So the observation, what will I see? So I'm going to see white precipitate being formed. So white PPT will be formed, which is soluble. Now remember, there will be differences when it comes to chloride, bromide, and iodide. So you have to keep an eye on what are those differences. So there is going to be a white precipitate that will be formed, which is soluble in the ammonia solution that I'll form, which is soluble in dilute or concentrated. It doesn't matter, which is soluble in dilute or concentrated ammonia solution. Okay, so this is also very important, that I can take ammonia dilute also, or I can take obviously if it's something is getting dissolved in dilute, obviously it will get dissolved in concentrate also. It makes sense, right? Okay, so now let's see how the reactions come. So that's the test. Now let's do the reaction. So this is how you're going to learn for every one of them. So very clearly you have to learn what is the test, what's the observation, and what are the reactions. So the reactions you have to convince, you have to prove to the examiner. So who gave the white precipitate and what happened to the white precipitate? Okay. So the first reaction that you're going to write, now for example, I am taking NaCl aqueous. Now remember, this is just a solution which contains the chloride ion. I'm not really interested in the sodium, but it's the chloride I'm interested in. And I'm adding, for example, silver 1 nitrate solution. Okay, so what's going to happen? Actually, the main thing that's going to happen is it's the chloride ion which is coming from here combining with the silver ion which is coming from here. Okay, so that's what the main reaction is. So this silver and the chloride, they combine together to form the AgCl solid. So this is the white PPT. Okay, so this is the white PPT, and then the Na and the NO3, they combine together to form sodium nitrate. Now in IGCSE you have learned that every sodium salt is soluble, every nitrate is soluble. So don't be surprised to see all of that in aqueous form. So that's the solid here, that's the white PPT. Okay, so if someone says write the ionic reaction, so the ionic reaction will be just written like this. Okay, so this is the ionic reaction. Ionic reaction, if they say, only show Ag plus aqueous plus Cl minus aqueous gives AgCl solid. That's the white PPT. That's the ionic reaction. So I can take this chloride from sodium chloride, potassium chloride, magnesium chloride, mango chloride. Doesn't matter. I can take chloride from anybody. Whoever can give me a chloride. So that's the first one is the molecular reaction. Second one is the ionic reaction. So in the exams, you can just write anyone. You can just go with the ionic reaction. It's much more easier. But when you write the ionic reaction, don't forget the ions are in aqueous form and the precipitate is the solid form. Okay, so that's the white precipitate. Okay, so now then the second point was that when I added ammonia into it, this actually got dissolved. So on adding ammonia solution. Now remember what ammonia solution I can use. I can use dilute or I can use concentrated. It doesn't matter. It's going to work either way. Okay. So on adding ammonia solution to the white precipitate. So something happened to the white PPT. So you have to, when you learn also, you have to be very, very clear. Again, these are possible long answer questions which can be for 3-4 marks. They can ask you this. Okay, so what happens now? So this is my white precipitate AgCl solid. It's a bit unusual equation for you because first time for you are studying what is called as a complex formation. You will study a lot of complexes in your grade 12 in your A levels, but let's have a look at this. So the ammonia here, ammonia solution here, okay, and it's going to combine with it to form what is called as a soluble complex. Complexes you will study in your A levels. That's where the transition metals and some ligands, they connect together to form complexes. So what you get here, I know it looks a bit unusual. Ag, and in the bracket NH3 twice, bracket closed. That's the, I know it's called diamino silver 1. Okay, you don't have to know the name, but I'm just writing the name so that it helps you to learn the formula there. And the 2 chloride, the chloride also gets kicked out here. Okay, so this is diamine silver 1 complex. Okay, it's a complex. You don't have to know its name. I'm just putting it there for you so that you have a bit familiar here. The important point is your solid precipitate got dissolved, it turned into aqueous. So that's what happens when the solid PPT disappears. So okay, so that's the entire reaction drama, what's happening. So the and then I think the equation is balanced. Let's check. I have 2 of that. I think it's balanced, right? Yeah, okay, good. Okay, so if you have any questions, this would be a good time. So how do we test chloride? I'm going to add silver nitrate solution. What do I see? A white precipitate. Who is that white precipitate? That's the AgCl. Once again, this is referred as silver 1 chloride. Silver 1 chloride. Again, the reason why we are saying 1 is because silver is a transition metal, oxidation number +1. So silver 1 chloride, and it's a white in color. And if I add ammonia solution into it, it could be dilute ammonia, could be concentrate ammonia. The white precipitate just dissolves in it. The reason why it dissolves, it forms a soluble complex. Okay, so this is the soluble complex, diamine. I'll just make a note. This is the soluble complex, and that's the reason why the white PPT simply dissolves. Okay, I'm done with chloride. If you have any questions, I'm still here. If you don't have any questions, could you just mention NQ in the Zoom chat? It is for memorizing, guys. Once again, I told you, I'm so sorry, inorganic chemistry is a lot of memorizing, but don't forget what I said. Memorizing is kind of useful sometimes. It gives you beautiful marks in the exam because it is straight from that only the examiner has to ask. They can't even convert this into an application question. Okay, so test for chloride, please make sure you learn them up. Now today's first thing which I started off was the reaction of sodium iodide with concentrate H2SO4. That's the observation, that's the equation. You got to memorize them because there's no other way around it, and the same thing is going to pop up in the exam. Okay, so you got to memorize them, write them out on a sheet of paper without looking and making all the reactions absolutely perfect. And same thing that goes here. Chloride, what's the test, what's the observation, and what's the reaction? Let's have a look at our second one, which is the bromide. We are in the last part of the 8C to finish off topic 8. And we'll be starting topic 9 today. So bromide test. Well, the good news is all the tests are exactly the same. There is only difference in the observation a little bit. So the test is exactly the same. So test means I'm going to add same thing, AgNO3 solution. Same thing what I did for chloride. I'm going to add silver nitrate solution. Your teacher probably might even arrange lab session for you to have an experience of actually doing this. Observation. So what you will see is now a cream precipitate. Now it's very annoying to do this experiment in the lab because you find it very difficult to distinguish between the cream precipitate and the white PPT. They're kind of overlapping. So so that's the second test which actually confirms that it's bromide. So there's a cream PPT which is formed. The test is the same, add silver nitrate solution followed by, okay, now here's the thing, for the testing of bromide, I have to follow it with ammonia, but I will tell you the comment which is a bit unique here, which you have to keep in mind, that the dilute is not going to work. The concentrated is going to work. You see, that's the difference between the bromide and the chloride. If you notice here, for the chloride, as I said, you can work with dilute or you can work with concentrate. Both is going to work. You see the difference now. For chloride, both are good. But when it comes to bromide, it can't work with the dilute. It has to work with the concentrate. So you've got to remember the small difference there. Okay, so cream PPT formed, which is insoluble with dilute ammonia. So I'll just write it very clearly so that you don't have any confusion. It's insoluble with dilute ammonia aqueous, but soluble with concentrated ammonia aqueous. So yeah, even if it's ammonia aqueous concentrated, I just still have to write aqueous concentrated, just means there is less water. But we don't do that with H2SO4 because H2SO4 is also a dehydrating agent. So if I have to say concentrate H2SO4, I will write H2SO4 liquid. Okay, but for others you can use that. So particularly with ammonia. Okay, so constant ammonia aqueous, or you can even, if it's confusing you, you can just, to be on the safe side, you can just write ammonia liquid and it's perfectly fine. Okay, so let's see how the reaction goes. Now the good thing is the reactions are exactly the same as that of the chloride, so that's the good thing. If you kind of memorize the chloride, you can use that to figure out the reactions, what's happening in the bromide, because it's exactly the same. You just have to change the Cl into Br, and that's about it. Okay, so I'm going to take, for example, sodium bromide. So I'm taking sodium bromide solution, but remember, it's not exactly the sodium which I want. I'm actually targeting the bromide ions coming from there, and I'm reacting this with the silver nitrate solution. So once again, it's not exactly the nitrate which I'm interested, it's the Ag plus aqueous which is coming from there. So this is silver 1 aqueous there, and so they're going to react together. So they're going to react together. I know they're going to react together to form the AgBr solid. So this is the cream PPT, correct? So I'm going to get here the AgBr solid. There you go. Plus I will get the sodium nitrate, and that's it. Okay, don't forget the examiner can give you, instead of sodium bromide, they can give you magnesium bromide. It doesn't matter. It's the same thing. You will still get AgBr solid. That's what you're going to focus on, right? Okay, so that's my cream precipitate. And then the second point said, if I add dilute ammonia, it's not going to work. But if I add concentrate ammonia, the precipitate actually dissolves. So the reaction, thankfully, is exactly like this. It is still going to form a soluble complex. So if you just learn this equation, you will actually use that to learn this one. So with concentrate ammonia, so this is my AgBr, the cream. Sometimes you might even see the words off-white precipitate. That also is fine. Off-white precipitate. Don't be surprised to see that. Exactly the same equation. I'm just using ammonia liquid there, just to make a point that this is concentrated. Okay, so the soluble complex has exactly the same formula. So that is a square bracket Ag, and in a small bracket there NH3, 2, and close a square bracket. Remember, these are called complex ions. You're going to study them exclusively only in your A levels. Okay, and then of course I have the bromide aqueous there, and that's it. All done. It's the same thing, diamine silver 1 soluble complex there. Okay, I'm waiting for your questions if you have. Remember, if you do this reaction with the dilute ammonia, that's not going to work. The cream precipitate is not going to dissolve with dilute ammonia. It can only work with concentrate ammonia. Okay, I'm done. Waiting for your questions. No questions? Okay then. So that was the test for bromide, and now let's have a look at the last one, which is our test for iodide. So remember, what we are currently doing is the test for halide, chloride done, bromide done. Let's have a look at the last one, which is the test for iodide. It's much shorter, because the precipitate that you will get here is not soluble in ammonia at all. So that's it. So you only have one set of equation. So the test is exactly the same. We are going to add silver nitrate solution. Okay, and followed by ammonia solution. Okay, now observation. Now, how is the observation of this different from chloride and bromide? So, quick recap, when it comes to chloride, I'm supposed to get a white precipitate of AgCl, which is soluble in dilute and or concentrate ammonia. For bromide, I'm supposed to get a cream precipitate, which is not soluble in dilute ammonia, but can dissolve in concentrate ammonia. Now we're trying to understand, so how is this different? So observation, I'm going to get a yellow precipitate. Okay, that's a yellow PPT form, which is insoluble in both dilute and concentrate ammonia. So this just doesn't get dissolved. Concentrated ammonia solution. Okay, so let's highlight all that. So it's the PPT is insoluble in both dilute and concentrate ammonia. So that means there is no second reaction, there is no soluble complex which is being formed. So we only have one equation which is happening here. So if I take my, for example, if I just take a sodium iodide as my source of the iodide ions, remember this is my source of iodide ions, and I'm adding silver nitrate, silver 1 nitrate solution. But remember, this actually is giving me the silver ions. That's what I'm interested in. So these two will react together to form the AgI solid. So that's the yellow PPT which I'm getting. And this yellow PPT is insoluble in dilute or concentrate ammonia. So these are good questions, particularly for MCQ, even for SQ structured questions. The question goes AgI solid plus the NaNO3 aqueous. Okay, I'm done. I'm waiting for your questions. If you have any, please let me know. So we finished the test for chloride, bromide, iodide. Yes, you got to memorize it. There's no other way around it. But direct questions in the exam, good questions for you to pick up straight, easy marks there. Any questions at this point of time? Could you just let me know if you have any questions? Please feel free to use the mic and speak. Otherwise, we are going to next page. Can you just type R for ready? If I can go to my next page. Just have a bunch of small equations. Okay, thank you. We're almost done. There is a small couple of points. A reaction of hydrogen halides with water. Very easy reactions. There are not too many really. It will finish very quickly. Reactions of hydrogen halides. This lesson has got a lot of equations, I know. But as I said, only those equations will come in the exam. So just have to be make sure that you learn them up. Reaction of hydrogen halides with water. Okay, so interestingly, whenever hydrogen halides they react with water. So when I say hydrogen halides, I'm talking of HCl, I'm talking of HBr or HI. Normally we avoid HF, but it doesn't mean that it can't work. Okay, so even HF for that matter. Okay, so this is what I'm talking about. So the point number one, whenever they react with water, they form acidic solutions. They form acidic solutions. So that means the pH is going to be less than 7. Okay, I'll give you a bunch of equations there. which you might find it good for reference. Hydrogen fluoride, if it's in gaseous form and you put that in water. Interestingly, there's an equilibrium set up here. Now, what happens is this guy here is going to lose a proton, right? So that means it acts as acid. And H2O, it acts as base because, proton acceptors. And don't forget, H2O is amphoteric. Don't forget that H2O is amphoteric. You know what that means? It can lose a proton, it can gain a proton. It can lose or gain proton. Okay, so don't forget, water is amphoteric. It can do both. So here the water accepts the proton there. So what I get now is the F negative, correct? Plus I will get here the H3O plus. If you want the physical state symbols, that's the aqueous there. Ions are always aqueous. H2O is always liquid. That was coming off as a gas. So if I put hydrogen fluoride gas into water, so ions are being formed here. And why is it acidic? Because H3O plus, it's actually an acid. It's a proton donor. Okay. Now, if I look at some other reactions here, now I don't find equilibrium in all of them. Okay, so it's just the equilibrium is present in the hydrogen fluoride one. Okay, so it's not that it's found in everybody else. So all other equations will go as usual. So I'll just write here. So maybe you can think of what could be the products. Okay, no difference there. They all act exactly the same way. And that's it. We're done here. So the HCl, same thing. I will get here chloride plus I will get here H3O plus. Similarly, bromide plus H3O plus. And the reason why they are acidic solutions, okay, so don't forget it's because of the H3O plus which is formed. That's where the solution becomes acidic. Okay, so if you want to highlight it, just remember, so due to H3O plus ions in water, solutions are acidic. So that's the reason why the solution becomes acidic. So that's the comment there, and I'm done. If you have any questions, please let me know. A very easy question. So reaction of hydrogen halides with water, all of them in gaseous state, all of them getting into aqueous. So this is all gaseous state. H2 is all liquid. All the ions are aqueous. And don't forget, all the ions are always aqueous. Okay, and that's it. If you have any questions, please let me know. Any questions? Easy. Reaction of hydrogen halides with water, all of them forming acidic solutions because of the formation of H3O plus. Okay. Now, almost the last heading is the reaction of hydrogen halides with ammonia. To finish this chapter. Reactions of hydrogen halides with ammonia. Okay, so now don't forget ammonia is a base. Don't forget hydrogen halides are proton donors, so they are acids. So you can expect what happens. It's an acid-base reaction which is happening, correct? Okay, just one comment I want to write as to why there was an equilibrium in this equation. I forgot to write. I'm so sorry. Just make a note that HF is actually a weak acid. It's actually it's a very weak acid. It can't really donate the proton very quickly. So that's why the equilibrium is existing. And in fact, as you go from HF to HI, HI actually is a pretty strong acid. It can release the proton very, very quickly. So it's good to know that this is the strongest acid here. Okay, so it can release the proton very, very quickly. So it has HI shows the strongest acid behavior. Okay, A reaction of hydrogen halides with ammonia and they form salts. They form white salts. Well, not surprising why white salts, because they're not transition elements really. Okay, uh, so acid-base reaction to form salt. Let's have a look at those equations. So for example, if I have ammonia reacting with HCl, now what you get here is, okay, so that's easy for you to understand this way. So I have HCl who is reacting with ammonia. So what you guys must understand that this one here releases the proton. Okay, so what happens to NH3? NH3 is a base. It has nitrogen as lone pair of electron. It can accept a proton and make a dative bond. All that you've studied before. So the NH3 gains a proton and changes into ammonium ion. Now remember, ammonium is NH4 plus, right? And the Cl here comes off as a negative ion. So that's basically ammonium chloride. So this is that's the white salt which you are seeing here. Okay. Now you could go on and do reactions by yourself. If I react an NH3 with HBr and HI, I will get similar equations. So this is HBr reacting with ammonia. So similarly, I will get here ammonium bromide. If I use HI with NH3, I will get ammonium iodide. They're all exactly the same. Okay, don't forget, all of them are solid, all of them are white solids. They're all white solids. Okay, that's it, we're done. Okay, any questions at this point of time? This is an acid-base reaction. Probably you may think why water is not being formed, because you have studied in IGCSE that acid and base reacts to form salt and water. In this case, you won't get water, guys. You have to understand the reason why you don't get water here, because your base ammonia does not have oxygen. Okay, so you're getting the salt, but you're not getting water here because your base ammonia has no oxygen. Okay, there is a small little point at the end. Use prediction with respect to fluorine and astatine. Okay, so I'll just write the heading, but we are not going to do anything on this one because it's kind of application area. So the last point in your curriculum here says make prediction about fluorine. Now fluorine, don't forget, is the most reactive, correct? Most reactive. And astatine is the least reactive. Least reactive halogen and their compounds. So what this point of the syllabus wants you to understand is what we have discussed, what happens to HCl, HBr, HI, what happens to NaCl, NeBr, NaI. We did everything using them. Now the syllabus says, okay, what if we give you HF, or what if I give you NaF? So based on those prediction, you just have to predict. Just keep in mind the trends. This is basically testing you on the trend. So you got to remember, as you go down, the reactivity decreases of the halogens. As you go down, the halide ions are more powerful reducing agent. As you go down, the oxidizing ability. Remember all the trends that we discussed in the previous class. That's what they're actually targeting. There's nothing more. We'll actually best do this particular heading in the past paper as questions. Okay. So, well, that's it. That's the end of this lesson. Let me know if you need any help, any doubts. We're going to start the next lesson shortly. Anyone has any questions on this one?